Dear students, so in today class we will discuss about the legacy database models, right? So as a part of legacy database model, we will discuss the two categories of legacy database models. So before going to the actual content of today presentation, we will go for the outline of the presentation. One is a hierarchical presentation, one is a network database model, and next one advantages and limitations, modern relevances. So in a hierarchical database model, we will discuss one by one. So hierarchical database model, it is name is suggesting that data will be organized in a one level by the another level, right? It is a tree kind of structure will be used to store the data. So what is a tree? Tree is a collection of parent and child, simple. So this is a one kind of tree. So it is not necessary should have two childs. So this we call it as a root node, this we call it as a internal nodes, this we call it as a child node, right? So it may have like this also, single, then also we can say it is a tree. So what is a tree and types of tree, how it is implemented, and different types of tree, you will study more details in a data structure subject. As of now, you remember what is a tree? Tree is a collection of root, parent node and child. So what in a every root node, like it is represent the starting of the data point. Like you can see one example. So there is a one company. So it is a parent company. So in a company there will be different departments, like department A, department B, something like that. So each employee is associated with a one department. So employee 1 is associated with the department. Similarly, employee 3 associated with the department B. So we can say this is a one root node and it is having two childs. Again, each sub child is having two separate nodes, or we can say it is a child. So this is the about brief introduction related to the hierarchical database model, right? Now we will see key characteristics of hierarchical database model. First one is a one-to-many relationship. So that means that there is a one data point. From that one database, there is a different parts data will be moving. Again, you can take here, there is a one data point, from there will be different data points. So that means that one data point to the, it is going to the two or more data points. So that's why we call it as a one-to-many relationship. So that's what one of the characteristics about the hierarchical database. Next one, each child has only one parent, right? Each child has one parent. What is the child? Employee 3 and employee 4 and employee 1, employee 2 is a child. So as per our characteristics, each child have only one parent. You can take employee 2 also having only one parent, employee 1 having only one parent. Similarly, employee A and employee B having only one parent, right? So this is the one of the characteristics. Next one is the data is organized in tree like structure. So as we said, this is a one data point, this is a one data point, all these are connected like tree kind of structure. So this is the characteristics about the hierarchical database model. So now you can see the hierarchical database model. We already covered this one, right? So next one, network database model. So what is a network database model? In a network database model, data is organized in a form of graph. So whereas a hierarchical model, data is organized in a form of tree. In a network database model, it is organized in a form of graph. So what is a graph? Graph is a collection of vertices and edges. So what is a edge? Edge is a some relation. Edge is a some relation. Vertex is a some point, any point. Like if I take this is a one point, this is a vertices. If I take one point, this is a one vertices. If it is having some relationship between the point A to point B, so we can say this is a one graph. So you will study more details about graph, types of graphs and properties of graph, all those things in a graph theory subject in a more detailed manner, right? So what is the key points in a network model? Data is stored in a form of graph. Also we can say it is a network, in a form of network. So records can have multiple parents. So now you can see this is a one child, let us say it is having multiple parents. Whereas a hierarchical model, it don't have multiple parents, it have only single parent. So that's why it is representing the one to many. Here network model, one child may have more than one parents, right? So this is one of the key point. Next one, record can have multiple chain records. So similarly, one record having multiple. Hierarchical one, it is present like one to many, but many to one is not present. Here it is a both are possible, many to many it is possible, right? So it is more flexible than hierarchical model. Why it is more flexible? Why it is more flexible? Because of data will be flow in hierarchical manner from one place to the many place like this. But in a network database model, it is not like that. One to many also possible and same time many to one also possible. So that means that as compared to the hierarchical model, more advanced flexibility is coming to the picture, right? So one more example also we can see, right? So now you can see example. So we'll see first characteristics and advantages, limitation, then we'll see the one example. Or else we'll see, okay, no problem, we'll see first example only. You can take the student 1, student 2, student 3, right? And instructor 1, instructor 2, instructor 3, and course A, course B, course C, course D. So one student may enroll the different courses like course A and course B. Same time, one instructor may two courses may handle the one instructor, right? So on one course they may chance act as a two instructor. Like take the course is a BTech. Let us say take the BTech, right? So in a BTech there will be different instructor for BTech. That is one is a mathematics faculty, one is a IMS faculty, right? So again in a BTech there will be different students like student 1, student 2, etc. Right? And again there is not compulsion that student may have only one course. Student may go for some other course like any specialized course. Specialized course EM may be associated. So that means that it is a many to many relationship are existed. A student can enroll the many courses and course can have many students, right? So this is the example about the network database model. So what are the characteristics? One character is graph structure. It is in a store in a form of graph. So as we discussed, what is a graph? Graph is a like nodes and vertices. Like so this is a graph kind of structure. Many to many relationships are exist like one relation may exist multiple many relation and multiple relation it may comes to the one relation. So it will use the pointer to navigate from one location to the another location because of it is following the some link. One more is it is a flexible navigation because of link is connected from one node to the another node So moving from one place to another place by using a link is a very easy. So that's the reason we can say it is a flexible navigation, right? Advantages: supports the complex relationship. So that means that, for example, one to one relationship. We'll take one more relation, one to many relationship. So which one is a complex? One to many is a complex relation as compared to the one to one relationship, right? So again you take the many to many relationship. Many to many relation is much more complex than the one to one, one to many to one. This is a more complicated one. So those kind of relationship you can able to develop with the help of network database model. Reduce the redundancy because of data is having relationship with the one node to the another node in a multiple fashion. There is a high chance to reduce the data redundancy. Better flexibility than hierarchical database. Why it is a better flexibility? Because of if one to many relationships are exist, right? So there is a chance to move one node to the another node. Two possibilities are there. If it is released again many to one, so there is a high flexibility from one place to the another place. Let us say this is A, this is B, this is D, this is D. Each node. So I want to travel from A to D. So I may go A to B, P to D, or A to C, C to D. So this is a one plausibility. If it is only one to many relationship, so then A, B, C. So if I want to go A to B, only A to B is the only possibility. So there is no other plausibility, right? So that's the reason we can say it is a better flexibility as compared to the hierarchical model, right? So limitations: it is a complex design. Why? Because of it is a many to many relationship. It is a many to many relationship. Difficult maintenance. Why it is a difficult maintenance? Because of it is many to many relationships that exist. So if it is many to many relationships are exist, you have to maintain the data each and every relation in separately. So links are used to maintain the how many links are there. So data will be very complicated manner. So in that, efficient data structure need to be used to store the all links in a network database. So that's the reason it is lead to the difficult maintenance. So navigation dependent paths, right? For example, tree is like this. Sorry, network database is model is like this. Let us say. So in that case, if I say this is A, this is C, B, D, you take. This is like E, F, right? If I want to write a query from A to C reach position with the help of A, F, B, C. That means that A to F, B to C, and C to F, and B to C, like this. Like this procedure I want to write. So what will happen? These two are exist, but this B to F is not at all existed. So that means that I may not navigate from the B to F. So there is no much more flexibility is not there to write a query. Some of the flexibilities are required. Flexibilities are rare, so that there is another flexibility I can write. So next one is a required specialized knowledge. So why it is required specialized knowledge? Because of you must know what are the links are existed from starting node to the ending node, or each and every node in a network database model. So that you should have thorough knowledge about the links and nodes in a network model, so that you can able to write the question in efficient manner. So this is one of the drawback for the network database model. So where is the application? Application will be used airline reservation system, manufacturer system, telecommunication, inventory management, etc. Because of I don't want to discuss in much more details so application why how it is used, because of we already covered the previous classes, right? So next one, so we'll comparison with the database model and relational model, right? So data representation will be stored in a legacy model, either point based, So pointer based, either maybe tree or graph kind of structure. Whereas a relational model, table will be stored on combination of rows and columns. So again, in a legacy model, relationship will be represent one to many or many to many, right? But a relation model, it will support one to many, many to many, right? But whereas the legacy models one to one relation is not supported. It means that, for example, my application is a very simple. So in that case, I use the relationship as a hierarchical model or network database model. This is one of the drawbacks. Data navigation. How the data will be navigation? It is a predefined path by using the links. Whereas in this one, set access using the SQL queries. Schema flexibility is less as compared to the relational database in a legacy models, right? Scalability is a poor scalability aware due to the some problems like flexibility of moving. So those kind of problems are there. So it is a less support to the flexibility, whereas a relational database it is efficiently supports. Programming, there is a requirement of complex programming because of it is a there is a some procedure well for data storing. So you must follow those data structure to retrieve the information, right? So there is a much more complicated programming is required to write to get those information. But whereas the relational model, it is not like that. You can efficiently fetch the information, right? So data integrity, so it is good in data integrity, whereas a very strong and with some integrity constraint is available in a relational database model. Performance is a high performance but fixed transaction. There is in this one good performance and complex queries also it will support. Whereas the legacy models is not user friendly, whereas the relational models are user friendly. It supports the Hadoop queries. It means that if you want to write the instantiation queries, it's like suddenly you want to write any query which is not you are expected previously. Hadoop means spontaneously, right? It is a very tough to write, but it will support in a relational database. So what is the advantages of legacy database model is a high performance, right? So one is high performance, efficient in a predefined paths because of we already know paths. So this is one of the advantage. Good data integrity and suitable for structured data, fast data retrieval. So why it is a fast data retrieval? Because of the data will be stored in a form of tree kind of structure, tree or network kind of mixture. So it will be having some link between the one node to the another node. So it is a fast we can move from one node to the another node. So suitable for structured data. If data is having some predefined structure like tree kind of structure or network kind of structure, so legacy data models you can use. But whereas a relational data you can use any of that. So limitations is a difficult to schema modification. If structure is defined, database structure, some structure is there, it is a very tough to change that structure. So that is one of the drawbacks. Poor scalability, you cannot improve the data as much extent you want. So complex programming, as we discussed why it is complex programming, right? So limited flexibility due to the predefined paths, not user friendly because of it is a very tough. So that's why it is a user friendly. It is not user friendly. Navigation based axis, right? Only navigation based only you have to answer. One more limitation is a very hard to support the Hadoop queries, right? So how these legacy models are relevant to our modern database, right? So first one is you will see hierarchical model. Hierarchical model is like file system, XML document, LDAP, organizational structure. These all are comes under comes under hierarchical model. So here I don't want to discuss what is a file system. You might already aware. LD XML document also. People, those who are study in a more details and web programming, right? LDAP, right? So LDAP is a lightweight directory access protocol, right? So lightweight means it is taking very less computation and less memory for those computation, those type of application we can say lightweight access lightweight applications. Lightweight directory access protocol, right? That means that there is a less requirement of memory, less requirement of computation is required for to run the this LDAP. What is the protocol? Protocol is some predefined rules to execute this application. Like for example, take the Gmail. When you are opening Gmail, so you enter the username and password. By backend, it will map whether it is a correct or not. If it is correct, it will open. Otherwise, it will not open. Everyone is aware, right? So for that one, what you will do? It will have some protocol. Like when you start entering the username into that username bar, so automatically it will check the backend. So that means that when you enter, it will start checking. So that means that there is a one instruction like user is starting, you can start executing backside. So this is the one type of protocol for Gmail. The people are using LDAP, right? So organization structure also you can use. This is the hierarchical concepts. So in a network, social media you can use this network concepts. Transportation system also you can use. Computer networks also you can use. Recommendation system. So what is a recommendation system? I'll tell you. Right, for example, these points students are able to understand, but this is a novel term, so that's why I am explaining what is a recommendation system. Like for example, you are shopping in an e-commerce company. Let us say you are purchasing some electric equipment, let us say mobile phone, right? So when you are typing the searching mobile phone, similar mobile phone will be displayed on your below of your mobile phone, say, which is selected. So how it is selecting? Based on your interest, you have chosen this mobile phone, right? So what is happen? It will start comparing in a database. It is how many mobile phone are having similar property with which you are selecting, right? So then start comparing with the other mobile phone which are exist in a database. Then all those mobile phone send as a recommendation on a basis of similarity. So similarity may be like they may put 90% similar or 80% similar, they may put some threshold. So if threshold is above the threshold value, so all mobile will go to recommendation. If threshold value is below that one, it will not show as a recommendation. So this type of application used in a real time environment, right? So in a modern database, how it is inspired by the legacy models. So graph data sets it will be there. It has connected, interconnected data from one point to the another point. So document databases also you can use NoSQL databases. So these NoSQL database and document database I am not discussing because we are already covered in the previous class, right? So next one is a relational database. Why they are less popular today? Because we are discussing many flexibilities are there, many advantages are there as compared in a hierarchical concepts and network databases, not concept, right? So why they are not popular? Because of relational database having offer the easier querying with the SQL as compared to the hierarchical database and network database. So that's the reason it is not as much popular as compared to the SQL. Schema changes are simpler. So in a relational database, schema changes is very simple, but in a hierarchical model and network database model, it is a very complicated task. So that's one of the reason. Better support the modern application. So modern application may be structured, may be unstructured or semi-structured. So in that cases, the hierarchical database model and network database models, it will not support, right? So only structured data only it will support. So in that case, this is a not that as popular. Next one is a easier maintain and scalability. If you expand your application, those application may not be support, but SQL it will support as much you can do, right? So in a current importance, understand the models helps in. So what is the today importance for learning the legacy model? So you can understand the evolution of the databases, how it is evaluated from starting a database to the till today. So and so we can understand the relationship between the different databases, right? So you may design the specialized system, right? For example, tomorrow you are the student and establish one new company. Because of each company to company requirements will change, right? For example, some other company which are started before your starting company, they are having some database, right? As per your requirement, you want to customize your database, right? So in that case, what will happen? You should know thorough knowledge about the which are existed in the previously, right? So based on the those existed databases, it automatically you will get some knowledge, and then you can able to customize the database as per your requirement. So thus we can say, so if you have enough knowledge, you can able to design a specialized system for as per your requirement, right? So it is giving the foundation for modern databases, right? So now coming to the summary of the databases. So what we discussed the hierarchical model, hierarchical database model. It will store the data in a form of tree kind of structure with one to many relationship. So network database model, it is stored in a form of graph structure. It will represent many to many. Advantages, there is some advantages and limitations we already covered. So how it is a modern relevance because of due to some graph kind of structure and evaluation and understanding of databases, you can design the special database as per your requirement, right? So now I am ending class today here. So thank you for watching. If you like my content, please hit the likes button and share to the your friends and needy people. If you have any queries, please ping into the comment section, right? So thank you for watching. We will meet in a next lecture.